Salam alaikum friends, welcome back to the channel. Younes Charfaoui is here, and always in the series about Kotlin for beginners, we are going to understand something called Kotlin Reified keyword. Let's get started. So here, for example, let's say I'm having a generic function. So this generic function, it takes parameter t as value, and here we are just printing that value. As you can see, we can call it with a string, this string. You can call it with an int, with float, and it will work just fine. Now, let's say that I want also to print the type of that value. So whether it is string, float, double, and so on. So what we can do something like following. Let's do just the expression. Maybe you can think that you can do something like that and do class.jar and do like just simple name. Or from here directly you can use simple name. But as you can see, the error here cannot use t as a reified type parameter. Use class instead. So just to make sure that we are on the same page, what will happen here is something called type erasure. We don't know the type at compile time. So if you see the decompiled code here, if you go to tools and go to Kotlin and here to compile it. So as you can see, it is just string. We are calling it with string, making something with string. The type is the value and so on. And so this is an object. It is an object. And as you can see, we deleted, there is no type t here. So what we can do as a solution to that, and also in the Java solution, because sometimes we want to know the type. So for something like the serialization or JSON something. So you have to know the type and you can make a generic just like that. So what you can do is just to pass the type as parameter. So let's do type, something like that, and do k class. And just it is of type t. Now this won't work because it is expecting an any here. All right, so we go back here and you do the bound to any. And then we can just simply print the type. And if you run it, so here you just have to pass the type also. So this string, I will have to pass the class here. So this float, so I put float.class like that. This is an int, I will put an int.class. And this is a string, I will have to put also a string. So you can't make here, for example, float. It won't work because this is int and this is float. Okay, it won't work. Just to put it as an int. Now, if you run this, it will work perfect because we are just passing the types. Kotlin reflection is not available, but as you can see, this is string, this is an int, and this is a float. Now, you can achieve the same thing with Kotlin, but with a simple keyword. What is the keyword? Is just for this t, you have to make it reified like that. Now, this won't work until we add something. Let me just delete that. And let me delete that also. And here. Now, this won't work until we do something called inline. That will work. And basically, we can print the following. T and class Java, for example, and simple name. And if you run it this time, it will work perfectly. As you can see, string, integer, and float. So this is how you can make it work. But why this is happening? So in Java, as we said, we can't pass the type because it will be erased. What the reified keyword will do in order to prevent the type erasure? Simply, it will replace it with the actual type. It will replace it with string, with the int, and with the float, I'm sorry. No, but how it will do it? It will do it using this inline. The inline keyword, we will do a video about inline, cross inline, and non-inline also. It will just copy the body of this function in the place of that. And while copying, it will get the information because if you are calling here something with a string, it will get that to a string, it will replace it with the string, class, Java, simple name. That's the idea. If you go here to the Kotlin and show bytecode here, decompile it, you will see what I'm saying. Here's the main. In the main function, what I was doing is just calling this tree function. What will happen with the inline keyword and the reified thing, it will allow this to copy this thing into the body of this main function. So you will see the print will happen here. But as you can see here, we are getting this string class simple name, integer simple name, and float simple name. As you can see, it retained this information while inlining the function. That's the main idea on how to understand what the reified keyword is doing. So reified keyword cannot work without this inline, and you can't get the information without the reified. So if you do something like that, it won't work. So this reified keyword is informing as part of inlining to just use the actual type it is passed. Something else the reified keyword allow you to do is casting and type checking, right? So let's say that I'm having this generic function. So this generic function will be t. It will accept a list of anything and it will filter something. It will return that list of t. Now this it will check if this it is a type of t. That's the first one we are checking. Here, if you go to the error, it will say cannot check instance of erase type because we don't know the type at runtime. Same thing for here. It can't check for sure it is check cast this any to T. Great. What you can do simply is to use the Reified keyword and the inline function here. So this will work fine. It will prevent this error, and it will this is a warning in fact, and it will prevent this error. Why? With the Reified keyword, we can substitute the real type here when aligning the function, and you can use it to check it. So the Reified keyword allows you to do this kind of thing. It allows you to do the type checking, the typecasting also, and also to use that T inside here as parameter and use its value. So this is the main idea about the Reified keyword. The main thing to understand here is that recompiled code. If you decompile it, to understand this thing, right? Always understand this thing, what is happening under the hood. As we saw earlier, we are just inlining the function, and while inlining that, we are getting the actual type. If I call this, for example, let me have just list of, for example, int, and do that, I don't know, filter something. Let me just filter, I don't know, just simple int here. And if I decompile it also, let me just go back to the compiled code here, decompile it. As you can see, we will do what? We will do the aligning. Here is the align start from here. As you can see, here is the check. Here is the filter. Okay, it's an instance of int. And here is the mapping. Mapping will happen here. Let me check exactly. Here is how it will cast. And while aligning this function, we are getting the information about the type T, which is an int in this case. Okay, so just remember about this critical concepts here. So I will just delete that to show it that again. Recompile that, please. So just remember that the Reified keyword with the inline keyword will allow you to copy the body of the function into the actual function. So this is the function. We are copying that into here, the main. That's why we are having those here. And while copying that using the Reified keyword, we are copying the information about the types, the integer, float, and string. So just make sure you are understanding this concept. So that's it for this video. Thanks a lot for watching this video. I hope you understand the keyword Reified with the inline. We do a separate video about inline, cross-inline, and non-inline thing, keywords here. Thanks a lot for watching again. Don't forget to subscribe to the channel and see you in the next videos. Salam alaikum.